Good day, folks. Welcome to my YouTube channel. If you're new here, please, guys, don't watch my video without subscribing. Subscribing doesn't cost anything, it's free. You just press subscribe and it will notify you if I upload any video. Now, this question, guys, it's about the rate of reaction. Now, when it comes to rate of reaction, guys, we're going to look at the factors that affects the rate of reaction, right? Now it says the reaction of calcium carbonate with an excess dilute hydrochloric acid is used to investigate one of the factors that affects the rate of reaction. Balance equation is as follows. It's a calcium carbonate with a acid, sorry guys, with an acid, and the product is that, and water and carbon dioxide that is produced. Now it says the same mass of calcium carbonate is used in an experiment, and the temperature of the hydrochloric acid in all experiment is 40 degrees Celsius. So the reaction condition in each experiment are summarized in the table below. We have experiment A, the volume of hydrochloric acid, it's 500. Experiment B, experiment C, it's all 500. Even the concentration of HCl is the same. So what has changed there is the state of division. The state of division, guys, sorry for that, is the surface area, right? Now 5.1, it says for this investigation write down the dependent variable. So the dependent variable here is the rate of reaction. Always the rate of reaction is the dependent variable. An independent variable, it's what has been altered, what has been changed here, which is the surface area or the state of division, right? Now, going to the graph, it says the carbon dioxide gas must be produced during the experiment A is collected in a gas syringe. The volume of gas collected is measured every 20 seconds, and the results obtained are in the graph below. Guys, if you're looking at this graph, it's a volume of carbon dioxide versus the time, right? If you're looking at the graph here, at 00 time, there was no carbon dioxide. As the reaction progresses, there's a volume of carbon dioxide captured there up until it reaches completion there. So the maximum amount that is produced for carbon dioxide is 500 cubic centimeter. Very important. Now it says what can be deduced from the graph regarding the rate of reaction during the time interval from 20 to 40. What can be deduced from the graph from 20 to 40? From 20 to 40, if you're looking there, the graph, the gradient is decreasing there. That means the rate of reaction is what? Is decreasing. So what can be deduced about the rate of reaction is what? Decreasing. If you look at the gradient there, do you see it's more steeper here and it's becoming less steeper there? So which means the gradient is decreasing. That means the rate of reaction is what? Decreasing. So from 60 to 120, 60 to 120, the gradient there is what? Is 0. So the graph here is flat. So that means the gradient is 0. That means the rate is equal to 0. Now in 5.3, it says calculate the average rate in cubic centimeter per second at which the carbon dioxide produced in the experiment. So the carbon dioxide there in 5.3, carbon dioxide there, guys, is the product. So we know our formula, it will be positive. Its rate is equal to change in volume over change in time. Where do I know it's a change in volume? It's a volume over time. So, and it's going to be positive there. I don't have to put the positive. So it's going to be V final minus V initial divided by T final minus T initial. When they say average rate, guys, that means you're going to take 2 points from the graph, which is the initial and the end. I'll take 0, 0 there. And then I'll take the last point there. I'll take I'll take, what is the point? It's 60 is to 500 there. So let me just calculate the rate. So so V final, the velocity final is 500, the V initial, it was 0, and the T final, it was 60 minus what? 0. And when you punch that in the calculator, you get 8.33 cubic centimeter per second. That's the rate in which the carbon dioxide is produced there. Now, in 5.4, it says, how will the volume of carbon dioxide produced in experiment B compared to experiment A? Choose greater than, smaller than, equal to. We're comparing B to A. B to A, B to A. Guys, if you're looking at the masses are still the same. The mass of the limiting is still the same. And it's just that the rate that will be different. So if the mass of the carbon dioxide, calcium carbonate, which is the limiting, is still the same, and what has been changed there is the state of division, so that means it will be equal. So it says how will be the volume that will produce there, guys, it will be equal. And the reason for that is because same mass of what? Of calcium carbonate, or you can say same mass of what? Of limiting, right? Now 5.5, it says the graph now drawn for experiment C on the same set of axes. So if we look at experiment C, because it has a greater surface area, so that means the rate, this is going to have the higher rate, and then followed by the granules, and then the last with the slowest rate is going to be experiment B, right? They said, how will the gradient of the graph compared to the gradient of A? So it will be greater because the C is greater. So the answer here is what? Is greater, because the gradient of C is going to be greater because it has a higher rate. So the higher the rate, the steeper the graph. So it says use collision theory to explain the answer there. So I'm going to write it here. 5.5, the first answer is what? Is greater. Let me repeat it here. And then using collision theory, guys, first thing, what is the difference between the A and C? Is the what? Is the A and C is the surface area. So C has a greater surface area than what? Than A. So what we will say, so it's very important to specify which experiment are you going to talk about. So it's experiment what? Experiment what? C, right? So I'm going to talk about experiment C. I'll say surface area of calcium carbonate, which is powder, is greater than that of calcium carbonate of what? In A is in what? Is in granules, right? That's very important. Alternatively, here you can say more particles exposed. That's the same point. More particles exposed, right? More particles exposed, or you can say more particles. That's one point, guys. More particles with correct orientation, right? The second point here, you can say more effective more effective collision per unit time. This is very important, guys. This is the second point. And then the third point, you will say rate of reaction. Rate of what? Reaction increases. Right? That's 5.5. Let's look at 5.6. It says assume that the molar gas volume at 40 degrees, it's 25.7 dm3. So this is molar gas volume. Calculate the mass of calcium carbonate using experiment A. Let's look at the ratio. We have the volume of carbon dioxide, which is 500 cubic centimeter when the reaction reaches completion, and then we told that volume, it's at molar gas volume. So what are we going to do in 5.6? We're going to change that volume into number of moles, right? That's the first thing that we're going to do. So that volume is what? Is 500 cubic centimeter. I'll divide it by 1000 to change it into 0.5 dm3. And then I change this volume. I'll change the volume into number of moles. Then I'll change by the formula that says N is equal to Vn. So it's going to be 0.5 divided by 20. What is that? Is 25.7. Yeah, that's 25.7. If you punch that in the calculator, we do not round off, guys, till we reach the final answer. It's going to be 0.0195 mole. These are the mole of what? Of carbon dioxide. And then what are we going to do? We're going to do the mole ratio. The number of moles of calcium carbonate is equal to the number of moles of what? Of carbon dioxide, because of the ratio is 1:1. So it's going to be 0.0195 mole. These are the number of moles of what? Of calcium carbonate, since the ratio is 1:1. And then, now that we have the mass, the number of moles of calcium carbonate, these are the number of moles of calcium carbonate reacted with what? With the acid. Was the acid HCl? Yes. Then, having this number of moles, we can convert into mass. Now we have the number of moles, we can convert into mass. So we say number of moles equal to mass over molar mass. And then the number of moles, this one, we're going to substitute it there. It's 0.0195. Mass is the one that we want. And the molar mass of the calcium carbonate, all the time, guys, doesn't change. It's 100 gram per mole. So when we cross multiply there, so the mass is going to be 1,95 what? Gram of what? Of calcium carbonate. They said calcium carbonate that did what? Used. So is the mass of calcium carbonate used. In other words, the mass of calcium carbonate reacted. Guys, I hope that makes sense. Please watch my video till the end. Don't forget to subscribe. Cheers, bye.